everyone, a box with a square base and open top must have a volume of 32,000 centimeters cubed. We're going to find the dimensions of the box that minimize the amount of materials used. So basically it's an open top here. Whoops, I forgot to finish this. Alright, so basically let's let for the box the B be the base. So you have this base here, and if you look at the volume, we know the volume equals base squared times height. So this is going to be our height. Now, we only need one square, so that's why we're doing it that way. Now, our volume is 32,000 equals base squared height. And we're going to solve for h, so that's going to be, height is going to be 32,000 divided by base squared. Now, we're trying to find the surface area, so the surface area equals, and we just have this one base because it's an open top. So that's just going to be base squared plus 4 base times height. And we can plug everything in, substitute, and we're going to get this equals surface area equals, let's see, base squared plus 4 times 32,000, it's your base, divided by B, your height. All right, so now we're going to take the derivative with respect to our base. So we're going to do S prime of B equals, and let me write that down again. We had the surface area, or let's just put S of B equals B squared plus 4 times 32,000 divided by B. So when you take the derivative, you're going to get, this is 2B minus, and you're going to minus because we can write this as B to the negative 1. Let's just write it like that. So it's going to be minus, let's see, 4 times 32,000 to the B to the negative 2, which is going to be B squared. All right. Now, we can simplify this as equals to 2 times B cubed minus 64,000. Factor out a 2 divided by B squared. So I just kind of made this B squared. I put everything over the same denominator. Basically, if you put a B squared here, then you have to multiply this by B squared as well. That's why you get the B cubed. Now set this to 0, and you're going to get, for the numerator, you get B cubed equals 64,000. Cube root both sides. So B equals the cube root of 64,000, which equals 40. So now that we have our B, that's our critical number. That's our C. So we want to minimize. So we're going to plug in some points for less than 40 and greater than 40. So we can't go lower than 0, but we can test if for 0 is less than B, it says less than 40. So basically we're saying if this is 40, what happens when B is less than 40? But we have to start at 0. So what's going on with that? Well, if you plug in a number into our derivative for S prime of B, you're going to get a negative number. So this is going to be negative. Now, for greater than 40, So B greater than 40. So if I plug in, say 50, then that means our derivative of B is positive if B is greater than 40. So therefore, since it is minimum, because it follows this rule here for our first derivative test for absolute extreme values, that means our B is 40, and we're trying to find surface area. So that's just going to be 40. It's really base times height. So that's going to be 40 times 20, and that will be your surface area. Thank you. Have a nice day. Bye-bye.